repeat it again. Now suppose circuit is like this. Now in this type of circuit, what is given? We have to find the equivalence resistance between A and B. Now here we can see that from A 3 resistance are connected, from B also 3 resistances are connected. So now what can we do? We cannot consider these and this point. So if I take any of this or this as X, okay, let us name it as X. So this will be also X. I want to find the resistance between this and this, but these 2 points are very important for us. So we can draw the equivalent circuit like this. Now from A to B there is one resistance R, means from A to B there is one resistance of value R. Then next, from A to X there is one resistance R. A to X there is one resistance R. So A to X there are two resistances of R. Okay. Now B to X there is one resistance R. B to X there is one resistance R. So B to X there are two resistances of R and R. So now it is simplified in this way. Now it becomes very easy. These two we can see it is in parallel. These two we can see it is in parallel. So in parallel, so 2R means 2 resistance of value R. So R by 2. Here also 2 resistances of value R in parallel. So R by number of times repeated. So 2, R by 2, R by 2. Now X point is not important for us because we want to find what? Resistance in between A and B. So means it will be what? These two will be in series. So we don't have to consider X because we want to find the resistance in between A and B. So these two will be in series in that case. So R by 2 and R by 2 in series. So R by 2 plus R by 2 gives R. So whole of this value will be R, and here down R. So A and B becomes R and R. These two are in parallel. So R EQ is equals R by 2. Once 1 by R, then add it. Then directly we can do that when two resistances are in parallel, R by 2. Now whenever we try to solve few problems, we face some problems that are not in series also, not in parallel also. Means when there are resistances more than 3 to 5, means 4 to 5, more than 4, okay, 5 or 6, then we will always try to find that whether it is in a different condition, that is in a Wheatstone bridge condition. So next one is our Wheatstone bridge condition. Now we will definitely study the proof and theory of this Wheatstone bridge condition when we will study Kirchhoff's law. But now when you go to solve questions, you will definitely find problems like this. So how to solve those? Whenever you see resistances which are connected in this way, okay, see from A here it is going X, then again B, again from here to Y, then 4, and in between there is one resistance. Then what is important here is we will study the balanced Wheatstone bridge condition. Okay, we will study this condition. Whenever this Wheatstone bridge is in balanced condition, it means that no current is flowing through this XY arm. Okay, no current is flowing in the mid resistance. Now when X and Y, yes, and this X and Y no current will flow means the potential of X and Y is same, that is why no current is flowing. And in that condition, this condition is only possible, we can say that this condition is only possible when R1 by R2 and R3 by R4 resistance values are same. This ratio and this ratio is same. So both the way we can say that when this arm current is not flowing, it means that these ratio are same, or these ratio are same means this arm current is not flowing. So when this current is not flowing, we will just remove this arm, so we will get the value here. So suppose it is like this, suppose all the values are R. For simplicity we are taking R. It can be 2R, 5R, 10 ohm, 12 ohm, anything. So R here, R here, R here and R here. So if I see from A to B, this arm is connected in series, this two and these two are connected in series. So 2R in here and 2R here, and finally these two are in parallel to each other. So two resistances of 2R connected in parallel, so 2R by 2. So answer will be R. So this is the question you usually see, which is solved in with the help of Wheatstone bridge principle. So this type of question we have also done in the previous one, but here and here there were no resistances, but now here are resistances. So potential at A is not equals to the potential over here, and B is not equals to here. So what we will do, we will put X and Y. Okay, now just let us see A here, B, X and Y. So A to X there is one resistance, X to Y there is one resistance, A to Y there is one resistance, B to Y there is one resistance, and B to X there is one resistance. Okay, so this becomes a Wheatstone bridge. So whenever you see a circuit like this, it is a question of Wheatstone bridge. And see the ratio, check the ratio, R by R, which is same 1. That means that XY there is no current which is flowing. So here it will be removed. So R and R in series, R and R in series, both are in parallel. So